Okay, so now we're going to look at some examples of discrete probability distributions and start to work with these. So it says, suppose you brought in 4 groups and asked them, do you know what the brand name KitchenAid is associated with? The number of people who could respond are listed below. 20 sets of 4 adults are surveyed. So I want to break this down a little bit. So what happens here is I bring in a group of 4 and I ask all 4 of them, do you know what KitchenAid is associated with? And all of the possible outcomes are listed over here on the right. So either 0 out of 4 people knew what KitchenAid was, 1 out of 4 people knew what KitchenAid was associated with, 2 out of 4 knew what KitchenAid was associated with, 3 out of 4 knew what KitchenAid was associated with, or all 4 out of 4 knew what KitchenAid was associated with. And then what you're going to see over here on the right side, these are the number of groups, or the number of groups of 4 out of the 20 that I brought in that knew what KitchenAid was associated with. So again, what's happening here is I'm bringing in 20 groups of 4, and the random variable x represents x, sorry, let me back this up. P of x represents the probability that x out of 4 people knew what KitchenAid is associated with. So it says, is the table above a probability distribution? Remember that in the last video we talked about the requirements for something to be a probability distribution. It has to do with this side right here, this P of x side. And remember, the 2 requirements that we needed, the first thing we needed to make sure is that all of our probabilities, all of our P of x values are between 0 and 1. And when you take a look through this list, they are all between 0 and 1, right? They are all valid probabilities. So on that front, I think we would say yes, because all the values are between 0 and 1. And then what's the other one? We need to make sure that if we add these up, they add up to 1. I'm just going to do this with the fractions. These all have common denominators, so we're just going to add the numerators. 1 plus 6 is 7. 7 plus 7 is 14. 14 plus 4 is 18. 18 plus 2 is 20 out of 20. That does equal 1. So we would also say the sum, remember we have this symbol for sum, the sum of the P of x values equal 1, right? So this would be yes. This is a probability distribution for 2 reasons. These are all between 0 and 1, and they all add up to 1. Now, finding the mean and standard deviation of a probability distribution. To find the mean, what we do is we are going to take the sum of all of the x's times the P of x's. So what we do is we basically multiply across, and then we're going to add up what we get. Then the standard deviation is a little bit more complicated. It's the square root of x squared times the P of x's minus mu squared. We're not going to worry about this one right now. It's not impossible to do, but we're going to use technology to rely on calculating this one, and I'll show you how to do that in a second. But first, let's go ahead and it says in this next question, in the space below, calculate the mean by hand, then move to the Excel spreadsheet to verify the mean and then find the standard deviation. So I'm going to actually work this up here, and then we'll bring it down below. So let's calculate what these means are. So we're going to multiply across. It's going to be 0 times 0.5, which is 0. And then 1 times 0.30 is 0.30. And then 2 times 0.35, which is 0.70. You might need your calculator for this, but I think I can handle these in my head, so I'm going to take care of that. Again, verify with a calculator if you're working through these with me. 3 times 0.2 is 0.6. And then our last one here is going to be, let's see, it's going to be 4 times 0.10, which is 0.4. And now what I'm going to want to do is, remember in our formula, when you see this right here, it says add them up. So we're going to take the sum of these. So we're going to sum all of these up, and we're going to get 0.3 plus 0.7 is 1. 0.6 plus 0.4 is also 1, and then we've got a 0, which is not going to change anything. So this is 1 plus 1. So the mean of this probability distribution is going to be equal to 2. So what does this say? Remember what an average is. It says on average, or the expected number of people that we could, if we brought in 4 people and said, do you know what a KitchenAid is associated with? You can expect that about 2 out of 4 people would know what that is associated with. So we know that the mean is equal to 2. Now, let's go to the technology and verify how to find the standard deviation. And we're going to double check the mean as well. So what you want to do here is we are going to want to use our Excel worksheet. Remember, when you open that up, it's probably going to open up to the one variable statistics spreadsheet. But we have a couple here along this bottom line. And this one here says discrete. And when I click on that discrete tab, I can enter these values in. You see that we're going to use this one on the left-hand side because we have the x's and the p of x values. So the x values are 0, 1, 2, 3, and 4. And then our probability values 0.05, 0.30, 0.35, 0.20, 0.10. And look, we do have our mean. We found our mean was 2. And then our standard deviation is, let's round this 2 places, 1.05. So our mean was 2, and our standard deviation for this example is going to be, sorry, let me get my pen back. Our standard deviation is going to be 1.05. All right, in the next video, we're going to take a look at one more example of a discrete probability distribution and start to ask some other questions based off of the probability distribution.